What is up? We're going to be going over a really quick review of some momentum concepts. So let's get into it. All right. First up with momentum, just what exactly is momentum? Okay, momentum is a vector, and it's a quantity that we usually use to describe motion. Some people will say it's like a quantity for knowing like how hard an object is to stop, but really it's our best way to just quantify motion. And the equation we use for it is going to be momentum, which is represented with a lowercase p, is equal to the mass, and that's standard units are always in kilograms, times the velocity, which is always in meters per second. All right. Other important piece with this is impulse, and impulse has to do with how much momentum changes. So momentum is a quantity. It can change, and anytime there is a change in momentum happening, we call this an impulse. All right, and impulse is usually denoted as a capital J. Now, it's really important to remember this symbol, capital J, is actually not on the AP Physics 1 formula sheet. All right, really, it is just the middle portion and this next portion over here. But yeah, they don't use capital J, but like a lot of texts do, so that's why we're having it there. All right, so a change of momentum. Remember, delta is the Greek letter delta is our symbol for change, so change momentum, and that means we could have a change in any of these things. It could be a change in the mass or a change in the velocity, so that's why both of those are in the parentheses. And then next we have a thing called the impulse momentum theorem. This simply deals with how those two things interact, and this ties together like a whole lot of other conceptual stuff. But if you think about if velocity has to do with momentum, well, if the velocity changes, momentum changes, right? Well, think back to motion and dynamics. What is the only way we can change something's velocity? The only way we can make something accelerate? That's if there is a force, a non-zero net force being applied to that object. If any time there's a net force, there's going to be an acceleration and a change of velocity. So the impulse momentum theorem simply tells us that if you apply a force to an object over some amount of time, that object is going to accelerate and its momentum is going to change. Okay? So that's how we can start kind of tying together Newton's second law, with dynamics and forces and momentum. Okay. The last little bit to cover would be units. If we want to talk about the units, there are two ways that we can calculate momentum and impulse now, right? So we have the regular momentum way, which is mass times velocity. And so that means our units are going to be units of mass, kilograms, times units of velocity, meters per second. So a kilogram, meter per second. That's our first way we can represent momentum. The other way is if you use the standard kind of notation for impulse, a force times a time. And a force times a time gives us a Newton times a second. Okay. Now, some people might think this is weird that you have two different units, but they're actually the exact same way of representing the same thing. So let's see. What is this? I know there's a way. Can I write on this? Oh my gosh. It's amazing. All right. 1 Newton is a kilogram times meter per second squared. It's a mass times an acceleration, right? Okay. So if I have a Newton times a second, that gives me a kilogram times meter per second squared times a second, right? And if I do a little bit of abracadabra, then all I have right here is a kilogram times a meter per second, or in other words, a mass times a velocity. So this would be our unit of impulse. This would be our unit of momentum. Both are totally equivalent to one another. So both show us the exact same thing. Okay. The last thing when you're going through this, Obviously, you don't want to have to be searching around on the formula sheet. Actually, I'm getting ahead of myself. What if you're trying to do something with momentum and impulse? The question has something, you know, there's a collision or an explosion. We know we wouldn't need to use momentum. However, there is not a constant force here. There's not just like one number we can plug in for F. If that's the case, then we need to have a graph. If there's a changing force, that force will be graphed over time. Okay? And the way that we can find the impulse for that is if we take the area under that curve. So if you shade in all of the area underneath this line, right, base times height of that would give us newtons times seconds. So the area under a force time graph is going to give us impulse. That's the really important thing to remember, that little bit down there. Okay? And then the last thing I was getting to earlier, if we need to find this stuff on the formula sheet, well, on the formula sheet, we have where is this stuff, right? Right here is where we're going to have our equation for momentum. And at the bottom is the impulse momentum theorem. If I have something change in momentum, I know that's equal to a force times some time interval. Okay? So I will see you guys later. If you have any other questions, you can write them in the comments. This is like the first part to a series. We'll be getting into conservation laws later, which is the, how we use all this stuff to then apply conservation momentum. This is just basic momentum and impulse right now. Okay? All right. See you guys later.